does not yield its truths easily, nor does it owe us explanations. It has existed for billions of years before us, and it will continue for billions more, indifferent to whether we solve its mysteries or not. But we are not indifferent. We are drawn to the unknown, compelled by the need to understand. We are not content to simply observe the stars, we must know what binds them together, what unseen forces weave the cosmic web, what invisible laws guide the dance of galaxies. If dark matter is real, its discovery will be a triumph, a confirmation that even the unseen can be understood, that our ability to decipher the universe extends beyond what our eyes can perceive. And if it is not real, if the forces we have long attributed to an invisible mass turn out to be something else entirely, then we will not have failed. We will have stepped onto a path even more profound, one that forces us to rethink the very nature of reality itself. Either way, we will not turn back. Because the search for knowledge has never been about comfort. It has never been about preserving what we once believed. It has always been about pushing forward, no matter how unsettling the answers may be. And so, we look to the void, to the quiet hum of gravity, to the distortions in spacetime, to the unseen hand shaping the cosmos. We build our instruments, refine our theories, listen to the whispers of the universe, knowing that somewhere, hidden in the structure of reality itself, the answer is waiting. And when we find it, we will not stop. Because the nature of knowledge is not to conclude, but to evolve. Every truth we uncover will lead to another, every mystery unraveled will reveal something even stranger beyond it. This is the pattern of discovery. This is the rhythm of understanding. And this is who we are, a species that refuses to stand still, that refuses to accept limits, that refuses to look at the infinite and say, this is beyond us. Because nothing is beyond us. Not if we are willing to seek. Not if we are willing to ask the impossible questions. Not if we are willing to stand at the edge of the unknown, and take one step further. And so, we go on. Because the universe is not done revealing its secrets. And we are not done searching for them. And so, we press forward, unrelenting, unafraid, stepping deeper into the unknown with every question we ask. The cosmos is vast beyond measure, a silent expanse of light and shadow, of forces we barely comprehend, of structures so immense that even the speed of light cannot cross them in a lifetime. And yet, we dare to believe that we can understand it. That is what sets us apart, not strength, not survival, but the audacity to seek. We are beings of stardust, shaped by the same physical laws that govern the galaxies, yet we are not content to simply exist within this reality. We must decipher it, unravel its patterns, pull back the veil that shrouds the hidden architecture of the universe. Dark matter is one such veil. A mystery whispered in the gravitational pull of galaxies, in the bending of distant starlight, in the invisible currents that shape the cosmic web. If it is real, then it is the shadow of something profound, a force that has shaped the universe since the dawn of time, unseen yet essential, like the scaffolding upon which all structure is built. And if it is not, if our equations have been a reflection of something we have yet to grasp, then we stand on the precipice of something even greater. The rewriting of the fundamental laws that govern existence itself. Either way, the universe does not hide its secrets out of malice. It does not withhold knowledge to test us. It is simply there, waiting for those who are bold enough to ask the right questions. And so, we do. Not because we expect easy answers. Not because we believe the search will ever truly end. But because it is in our nature to reach beyond what we know, to challenge the darkness, to refuse to accept that there are limits to what we can understand. One day, we will find what we seek. We will see the invisible. We will grasp the forces that shape the cosmos, not as distant concepts, but as fundamental truths woven into the very fabric of reality. And when that day comes, we will not stop. We will look beyond, toward the next great mystery. For knowledge is not a destination. It is a path, winding ever onward, leading us further and further into the infinite unknown. And as long as there are stars in the sky, as long as there are minds that dare to wonder, we will walk that path. Forever searching. Forever reaching. Forever moving toward the next horizon. And so, the search continues. Not because the universe demands it, but because we do. Dark matter, real or not, is just one chapter in the endless story of discovery. Whether it is an invisible mass threading the cosmos together or an illusion pointing us toward an even deeper truth, it has already served its greatest purpose. It has made us question, made us explore, made us push the limits of what we thought was possible. This is the nature of science. Not the pursuit of certainty, but the willingness to stand at the edge of the unknown and take one step further. Because the cosmos is not static, and neither are we. We are the explorers, the seekers, the restless minds who refuse to accept that there is nothing more to learn. And as long as the universe remains vast and full of mysteries, as long as there are forces yet to be uncovered, questions yet to be asked, we will keep searching. Not because we expect to find an end, but because the search itself is what makes us who we are. Phantom matter. Does dark matter truly exist? Somewhere in the silent abyss of the cosmos, hidden beyond the veil of human perception, lies one of the greatest mysteries of modern science. We see its influence, we map its presence, and yet, it remains unseen, elusive. The universe, as we know it, should not hold together. The galaxies should be unraveling, their stars flung outward like autumn leaves caught in a whirlwind. And yet, they persist, bound by an invisible force, one we have come to call dark matter. For nearly a century, its existence has been inferred, not by direct observation, but by the subtle whispers it leaves in the cosmic fabric. It does not emit light, nor absorb it. It does not interact with the electromagnetic spectrum. And yet, its gravitational grip bends entire galaxies, distorts spacetime, and sculpts the grand cosmic web that stretches across the void. The idea of dark matter was born out of necessity, a ghostly scaffolding invoked to explain what physics could not. In the 1930s, Swiss astronomer Fritz Zwicky first noticed that galaxies in distant clusters moved too fast, as if they were being held in place by something unseen. Decades later, Vera Rubin confirmed this phenomenon in spiral galaxies, revealing a paradox: their outer stars should be flung away into the void, yet they remain tethered, as though held in place by an invisible force. This was the first compelling clue that something beyond ordinary matter, beyond anything we could see, was shaping the cosmos. But what is it? The search for dark matter has led scientists down countless pathways, from vast underground detectors to high-energy particle collisions, from galactic surveys to computer simulations of the infant universe. The leading theory suggests that it is composed of exotic particles, possibly weakly interacting massive particles, or WIMPs, so elusive that they barely interact with the known forces of nature, except through gravity. Yet, despite decades of searching, the cosmos remains silent. No direct evidence of dark matter has been found. No confirmed particle detections. No conclusive interactions. Nothing but its gravitational shadow, stretching across the universe. Some have begun to wonder, what if dark matter isn't real? What if we have misinterpreted the laws of the universe themselves? An alternative perspective challenges the very foundation of our understanding. Instead of dark matter, what if gravity itself behaves differently on cosmic scales? Theories such as modified Newtonian dynamics, MOND, propose that our equations of motion require subtle corrections in the depths of intergalactic space. Others suggest that gravity may emerge from deeper, hidden principles of reality, perhaps from extra dimensions or unknown aspects of quantum mechanics. Even Einstein's theory of general relativity, the bedrock of modern cosmology, is not immune to scrutiny. Could it be that our understanding of spacetime is incomplete? That an unseen force or structure is shaping the universe in ways we have yet to grasp? And yet, the cosmic evidence remains compelling. Maps of the early universe, like those revealed by the cosmic microwave background radiation, show ripples in spacetime that align almost perfectly with the predictions of dark matter models. The gravitational lensing of distant galaxies, where space itself bends under an invisible mass, paints an undeniable portrait of a universe shaped by unseen hands. But still, the question lingers. Are we chasing shadows? Could dark matter be a phantom, an illusion born from our own incomplete understanding of the cosmos? Or is it truly there, waiting just beyond the limits of our detection, like a specter at the edge of perception? For now, we remain on the precipice of discovery, caught between belief and uncertainty. The universe whispers its secrets in the language of gravity and light. And we listen, ever searching, ever wondering. Perhaps the answer lies in a realm we have yet to explore, one beyond our current reach, beyond even the boundaries of known physics. Could dark matter be something more than a mere collection of invisible particles? Some theorists have speculated that it could be tied to the deepest structures of spacetime itself, woven into the fabric of the cosmos in ways we have yet to comprehend. One possibility suggests that dark matter is not made of individual particles, but is instead a manifestation of something more profound, the hidden geometry of the universe. In the framework of extradimensional physics, some models proposed that what we perceive as dark matter could be the gravitational influence of matter residing in higher dimensions, realms beyond our three-dimensional space. In such a scenario, we are not detecting an unseen substance, but rather the ghostly pull of objects that exist outside our perceptual horizon. Other radical theories push the boundaries even further. The concept of gravitational entropy, the idea that gravity itself is not a fundamental force, but an emergent property of microscopic quantum interactions, suggests that dark matter might not be a thing at all. Instead, it could be the residual imprint of cosmic entropy, the statistical residue of deep, underlying physics we have yet to understand. And yet, our most advanced detectors, buried deep beneath the earth, shielded from cosmic noise, waiting for the briefest flicker of an interaction, have seen nothing. The Large Hadron Collider, humanity's most powerful tool for probing the subatomic world, has smashed particles together at unimaginable energies, searching for signs of exotic physics. Still, dark matter eludes us. So we must ask, if an idea, no matter how well it fits our observations, cannot be directly tested, should we continue to believe in it? Science is built on the premise that theories must be falsifiable, that evidence must guide us. And yet, dark matter persists as an enigma, a cosmic paradox. If it exists, it holds the galaxies together, sculpts the large-scale structure of the universe, and whispers to us through gravity. If it does not, then our entire framework for understanding the cosmos may need to be rewritten. Somewhere, hidden in the vast ocean of the unknown, the truth awaits. It may be buried in the echoes of the Big Bang, imprinted on the cosmic web, or concealed within the mathematics of a yet-to-be-discovered theory. The universe does not easily give up its secrets. But we, fragile beings on a small world orbiting an ordinary star, have dared to question, to seek, to unravel the unseen. And in the end, that pursuit, the relentless drive to understand, is what defines us. The search for dark matter continues. And with it, the search for the very nature of reality itself. But what if the answer is not in the vastness of the cosmos, but in the nature of reality itself? Some scientists propose that dark matter is not a missing mass, but rather a flaw in our perception of space and time. Perhaps the way we measure gravity, the way we define motion, or even the way we perceive the passage of time is incomplete. Could dark matter be an illusion born from an assumption we have yet to question? One radical hypothesis suggests that our universe is not three-dimensional, but instead a holographic projection, an intricate pattern of information encoded on a distant cosmic boundary. In this framework, dark matter could be a byproduct of how gravity emerges from this projection, a ghostly imprint left behind as space-time unfolds in ways we do not yet understand. Even more mind-bending is the possibility that dark matter is a remnant of a past universe, an echo of physics that predates our own. Some cosmologists suggest that just as a fire leaves behind embers long after its flames have vanished, our universe may carry the signatures of forces and particles that no longer exist but still influence the cosmos today. Or, perhaps dark matter is not a missing ingredient, but rather a side effect of a deeper symmetry, one that connects the visible and the invisible, the known and the unknown. Theories like supersymmetry predict the existence of partner particles for every known particle, and if such a framework is correct, dark matter may be the first glimpse we have into an entire hidden sector of the universe, a parallel world of particles and forces that interact only through gravity. But despite all these theories, we remain in the dark. The silence of the cosmos is deafening. Every attempt to directly detect dark matter has failed. Every new experiment refines our understanding but brings no breakthrough. The questions multiply, while answers remain elusive. And so, we find ourselves standing at the edge of the unknown, staring into the cosmic abyss, knowing that something profound must be waiting there. Perhaps the discovery of dark matter, or the realization that it never existed, will redefine our understanding of the universe itself. For now, the search continues. The universe, in all its vastness and mystery, remains a puzzle we are only beginning to piece together. But one truth is certain, the cosmos is far stranger, far more wondrous, than we have ever imagined. And perhaps that is the greatest revelation of all, not just the existence of dark matter or its absence, but the realization that we are still at the dawn of understanding, standing on the precipice of a deeper truth about the cosmos. For centuries, humanity has gazed at the stars, believing that the universe was nothing more than what we could see. First, we discovered that our own world was not the center of the cosmos. Then, we learned that our sun was just one of billions in the Milky Way. Later, we realized that our galaxy was just one among countless others, woven into a vast cosmic tapestry stretching beyond imagination. And now, we confront the possibility that even this vastness is but a fraction of reality. If dark matter exists, then the universe we know, the stars, the planets, the very atoms that make up life, is merely a whisper of a much greater unseen realm. If it does not exist, then the laws we have relied upon for a century may need to be rewritten. In either case, we are faced with the same inescapable truth: the cosmos is still hiding its deepest secrets from us. But history has shown that we are capable of uncovering them. The same curiosity that led ancient astronomers to chart the heavens, the same drive that propelled us to the moon, the same ingenuity that built machines capable of peering into the depths of space, this is what defines us. One day, we will know. One day, whether through the flicker of a distant gravitational signal, the whisper of a newly discovered force, or the sudden collapse of an old theory in the face of undeniable evidence, the veil will lift. And when that day comes, when we finally glimpse the true nature of the cosmos, we may find that reality itself is stranger than we ever dared to dream. But until that day arrives, we remain wanderers in the dark, pilgrims of the unknown, guided only by the faint glow of understanding that flickers on the edges of discovery. The search for dark matter is more than just a scientific endeavor. It is a testament to the resilience of human curiosity, to our refusal to accept the limits of our knowledge. It is a reminder that the universe does not yield its secrets easily, that each answer we uncover births new questions, and that the deepest mysteries often lie hidden in the spaces between what we know and what we have yet to learn. Perhaps the answer will come not from a new particle, nor from a modification of gravity, but from something wholly unexpected, something that rewrites the very way we perceive reality. Maybe the fundamental nature of existence is not what we think it is. Maybe we have been looking at the problem from the wrong perspective all along. And yet, in the absence of certainty, we persist. Telescopes will continue scanning the heavens, mapping the distortions of spacetime, searching for the invisible fingerprints of dark matter. Particle accelerators will continue smashing atoms, probing deeper into the quantum realm, searching for exotic forces beyond the standard model. Theoretical physicists will continue refining equations, constructing new models, challenging old paradigms, searching for a unifying principle that brings clarity to the unknown. We are driven by the same force that has guided every great discovery, the simple but profound desire to understand. And so, as we drift through the silent expanse of the cosmos, as we turn our instruments to the void, as we search for what may or may not exist, we are reminded of a simple truth: the universe does not wait to be understood. It simply is. But we, fragile beings bound to a small world, have chosen to seek, to question, to challenge, to explore. And that, perhaps more than the existence of dark matter, more than any discovery we have yet to make, is what truly defines us. And so, the question lingers, not just in the minds of scientists, but in the very fabric of our understanding of reality. Is dark matter truly out there, silently sculpting the universe, an unseen architect of the cosmic order? Or is it a shadow we have cast upon the unknown, a construct born from the limitations of our own theories? For now, we stand at the boundary between belief and evidence, between what we think must be and what we have yet to confirm. This is the threshold of discovery, where science meets philosophy, where mathematics becomes a language for the infinite. Perhaps in the coming decades, a detector buried deep underground will finally register a whisper of an interaction, proof that dark matter is not just a phantom, but a real entity shaping our universe. Perhaps the next generation of space telescopes will uncover a subtle distortion in the cosmic web, revealing the presence of something far stranger than we ever imagined. Or perhaps, as we peel back the layers of the cosmos, we will find nothing at all, nothing but the echoes of our own assumptions, dissolving into the void. But that is the nature of the journey. To seek. To question. To stand at the edge of the great unknown and take one step further. For as long as we have gazed at the stars, we have searched for meaning in the vastness. And whether dark matter exists or not, whether it is found or abandoned as a theory, the pursuit itself has already revealed something profound, not about the universe, but about us. We are the universe's way of understanding itself. We are the explorers, the dreamers, the restless minds that refuse to be satisfied with the surface of things. We are the ones who look into the darkness and refuse to accept that it is empty. The search continues. The universe waits. And somewhere, hidden in the fabric of space-time, the answer is already there, waiting to be found. And so, the question remains, suspended in the vast silence of the cosmos, like an unfinished thought in the mind of the universe itself. What if the answer has been before us all along, hidden not in the distant reaches of space, but in the way we perceive the fundamental nature of reality? What if dark matter is neither an invisible substance nor a missing piece of the cosmic puzzle, but instead a reflection of our own limited understanding, an artifact of equations not yet complete, of laws that whisper to us in a language we have yet to fully decipher? The greatest revolutions in science have not come from confirming what we expected, but from overturning what we thought we knew. When Newton's laws failed to explain the strange orbit of Mercury, Einstein revealed that space and time themselves were fluid, bending under the weight of gravity. When physicists sought to understand the inner workings of the atom, they discovered an entire world of quantum uncertainty, where particles flicker in and out of existence, where cause and effect become blurred, and where reality itself seems to be woven from probabilities rather than certainties. What if dark matter is leading us toward another such revelation? Perhaps we are on the cusp of a new era in physics, one where the universe is no longer described merely as a vast collection of galaxies and particles, but as something deeper, more intricate, more interconnected than we ever imagined. Some theorists have dared to suggest that what we call dark matter could be the first sign of a hidden cosmic structure, an unseen framework woven into the fabric of spacetime itself. Could it be that gravity is not simply a force, but a consequence of something even more fundamental? Could the laws of physics, as we know them, be merely the surface layer of a reality that extends beyond our ability to measure, beyond even the reach of our imagination? And if that is true, what else might we have overlooked? What other secrets lie waiting, just beyond the horizon of discovery? For now, the universe holds its silence, its mysteries intact. The equations remain unsolved, the experiments unfinished, the data inconclusive. And yet, we continue. We build our telescopes, our satellites, our particle colliders. We map the galaxies, track the movements of stars, listen for the faintest echoes of forces we cannot yet detect. We stare into the abyss, not with fear, but with wonder. Because the greatest discoveries, the ones that truly change the way we see the universe, are never just about answering questions. They are about learning how to ask better ones. And so, we ask, is dark matter real? Or is it something else entirely, something stranger, something deeper, something waiting to be understood? The search does not end here. It has only just begun. And so, the search stretches forward, a thread woven into the grand tapestry of human curiosity, reaching beyond the limits of our knowledge, beyond the boundaries of our perception, into the depths of the unseen. Perhaps dark matter is out there, silent and patient, a cosmic riddle waiting for the right question to unlock its secrets. Perhaps, in some distant future, a new theory will rise, one that does not simply explain dark matter, but dissolves the need for it altogether, replacing it with an understanding so profound that our current models will seem as primitive as the celestial spheres of ancient astronomers. If history has taught us anything, it is that the universe is always more complex, more beautiful, and more mysterious than we first assume. Every answer leads to new questions.